What's up, everyone? Welcome back. Patrick here. Moving on to the next question. So we're told that the cost of factory space is allocated to three types of inventories: raw materials, work in process, and then finished goods. And then the inventories use factory space in the ratio of 1/8 to 1/3 to 5/6, respectively. If the factory space is 10.2 million square meters at a cost of $19.313 million, how much of the cost should be allocated to each inventory? So what we're doing in this question is we're figuring out how that cost of $19.313 million is going to be allocated to raw materials, work in process, and then finished goods. Right? That's what the question is asking for. So to do that, we're going to have to use this ratio. And so what I'm going to do is I'm actually going to take this ratio here and I'm going to convert it to percentages of each of these inventories to see what percentage of the factory that each of these take up. And then that percentage we could just multiply for all three respectively by this, and then we'll get those amounts. Now, these fractions here, they're not the percentage, they're part of the ratio. So that's one thing I want to mention. Let's say that instead of fractions, we were told that the ratio was 2 to 3 to 5, for example. So for every 2 square meters of raw materials, there's 3 square meters of work in process, and then 5 square meters of finished goods. If we wanted to take this ratio here and convert it to percentages to see what percentage of the factory space each of the inventories is taken up, we would add these up, 2 plus 3 plus 5, which is 10, and then we would divide each one by that total number. So we'd have 2/10 for the raw materials. We'd have 3/10 of the work in process, and then we'd have 5/10 of the finished goods. Right, so that's how we get the percentages. These are in fractions. The percentages could be in fractions. They could be in decimals. So notice 2/10, that's the same as 0.2 or 20%. 3/10 is 0.3 or 30%. And then 5/10 is 0.5 or 50%. Right, so personally I usually actually leave it in fractions. And then notice that here, when we add all the fractions up, they add up to 1. Or if we add up all the decimals, they'll add up to 1. Or if we add up all the percentages, they add up to 100%. Okay, so when you get these percentages or these fractions here, they should always add up to 1 or 100. Notice how if we add these up, they don't add up to 1 or 100. And same thing here. If you add these up, they're not going to add up to, those are fractions, they're not going to add up to 1. So I don't want you getting confused. I wanted to mention this, that these fractions here are the same as these fractions. These fractions, because they're within a ratio, are like these numbers. We're still going to have to go through that same process of adding all of them up and then dividing each fraction by that total to get these fractions over here, to get the actual percentage of factory space that's being taken up. And then once we have these fractions, we'll just take them and multiply them by this cost to get each respective allocation. All right, so sometimes the ratios could be whole numbers, sometimes they'll be fractions. So in this case, the ratio is fractions. So what I'm first going to do is I'm going to total these up. So we'll have 1/8 plus 1/3 plus 5/6. Common denominator would be what? 24. So we'd have 3. Actually, let's do it over here. 3/24 plus 8/24 plus 20/24, like that. And then notice that if we add up the numerators, that would be 31/24. Right? So this 31/24 is like that 10 that we got with that other ratio that I was dealing with when we had the whole numbers or the integers in the ratio. So now what we got to do, if we want to find out, so we got that total number. Let's put it over here, 31 over 24. So now if we want to find out the percentage of factory space that raw materials are taking up, we would have to take the 1 over 8 and divide it by 31 over 24, which would be like 1 over 8 times 24 over 31, right? We flip that fraction, and then 8 goes into 24 3 times, so we'd end up with 3 over 31. So that's the percentage of factory space that raw materials are taking up. Then if we wanted the percentage that work in process is taking up, we'll take 1 over 3 divided by 31 over 24, which is like 1 over 3 times 24 over 31, which would give us 8 over 31. And then the percentage of finished goods, we would take the 5 over 6 divided by 31 over 24, which is like 5 over 6 times 24 over 31. 6 goes into 24, 4 times 5 gives us 20 over 31. Right, so those are the percentages right there, or the fractions. And notice if we add up all these fractions, 3 plus 8 plus 20, what does that give us? It gives us 31 over 31, which is 1. Remember, these fractions should add up to 1. So those are the fractions that we use. So we would take this amount, multiply it by 3 over 31, multiply this amount by 8 over 31, and then multiply this amount by 20 over 31, and that's how we would get the allocated costs. And when you do that in your calculator, taking that amount, multiplying it by the fractions, you get these respective amounts over here. So $1.869 million gets allocated to raw materials, $4.984 million goes to work in process, and then $12.46 million goes to finished goods. And you can also do a final check with these answers. You could take these, add them up. What should they add up to? Well, they would add up to that total cost. Also with this question, or just questions in general, be careful what they're asking for. They're asking how should the cost be allocated. Notice how the 10.2 million square meters, we didn't even use that at all. But if it asks how much of the space should be allocated to each inventory, then instead of $19.313 million, we'd be using the 10.2 million square meters. Right, so you apply this ratio to whatever they're asking for. Right, so these here are the final answers.